Right, so let's go ahead and get started. Everyone, welcome back to the final session of HATRA. I'm now officially the chair. Will Creighton, nice to meet you all. And we have one talk in this session, which is the goals of the Luau type system. This is our a follow-on paper to some of the earliest work at HATRA. And then following this, there will be a discussion about many of the things you saw here today. So if you'd like to participate in a small group discussion about all kinds of human aspects of types and reasoning assistance, please hang around for that. And otherwise, Alan, take it away.
Cool. All right, thanks, Will. All right, so as you can see from the title, this is a follow-on paper to the goals of the Luau type system paper that we had at HATRA 2021. And I am still actually hearing echo. I am going to have to just like plow through that. But if you hear me stumbling, it's because I am hearing my own voice repeated in my head about a second or two after I say it, which is quite distracting. Right, okay. So the structure for this talk.
Alan, maybe just for the talk, you could just like take your headphones off and mute everything and take no sound out of the stream, and that way we won't be bothered. We are not going to interrupt.
Here I am taking my headphones off. Okay. Let's try.
Hello, Alan, can you hear us? Thumbs up if you can hear us in the video. Sorry, the reason why we're full alert is we can't hear you. You went muted somehow. So it's important at least that we hear you, even if you cannot hear us. So just keep talking and we'll let you know when we hear you.
Alan says something.
Maybe, Alan, do you want to try and disconnect from the Discord and rejoin? Optimistically?
All right, ABC 1 2 3. Can you hear me this time?
Yes, we can.
Right. Okay. Can you see my slides?
Yes.
Right. Okay. I'll start again from the top. Right. Hello, everybody. Welcome to a follow-up talk from the Goals of the Luau type system position paper that we had at 2021. And so I'm going to do uh, a recap of what was in that talk. So that's going to be probably about half the material. Is for people who weren't here 2 years ago. And what did we say then? And then there's a couple of things that I'm going to report on of like what we've done about implementing the goals that we had there. The goals have basically not changed, but we have a bit more of an idea about what we're doing in order to implement those goals. So in particular, I'm going to talk about the way that we're using semantic subtyping, like why are we using semantic subtyping, because that's not an obvious topic for a talk in the human aspect workshop. And the other progress report I'll say is we have refined the way that we are thinking about gradual typing. So even though gradual typing is like a well-worn topic, there's probably 20 years worth of work on gradual typing, we are taking a slightly different view of this than you'll find in most literature. So, and then after that, we'll have I'll say a bit about like other stuff we've got coming down the pipeline, and then like Q&A. Right. Okay. So, 2 years ago, we had a position paper about what the goals of the Luau type system is. So, I can hardly encourage reading that paper and going and watching a 2-year-old video. Right. So the first thing is, why on earth are we doing like why is Roblox in the programming languages business? Right. Well, you might be under the impression that Roblox is a games company, but we're not. Okay. So if you're going to come away with one slide worth of information out of this talk, this is that slide. We are not a games company. Okay. Right. So what actually are we? So we are a platform company. So, so we provide the technical infrastructure that other creators use in order to create virtual experiences. And the majority of those virtual experiences are multiplayer games. So a lot of people use Roblox in order to create games. But like I said, we are not the games company, we're the infrastructure company. Um, and so what this looks like is like we have a rough dividing line about what we expect Roblox to provide versus what we expect the creators to provide. It's not completely like cast in stone, but this is roughly it. Is that the creators get to do anything fun. So we think, is this an amusing thing to do? So like, are you doing storytelling? Are you creating art assets? Are you providing music? Are you like looking at gameplay? Right, all of that is fun. So we expect that the creators are doing it. Whereas if it's boring, so like implementing a physics engine or implementing a rendering pipeline or blah 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 blah. So there's a lot of stuff that is dull that goes into creating multiplayer games. And the idea is that Roblox does that. And you'll notice somewhere down in the middle of that list, there's programmability. Okay, so one of the things that Roblox provides is the scripting environment that is used by creators when they discover any kind of interactivity that isn't just baked into the physics engine. They will have to actually write some scripting for it, right? And that scripting is written using the Luau programming language, and that is why Roblox is in the programming languages business. Right, so we are providing this scripting environment for creators on Roblox. And the profile of what these creators look like is drastically different than the creator profile for most programming language environments. In particular, we are serving a remarkably heterogeneous creator community. So this diagram comes out of our annual report. I heartily recommend, if you're working for a company, going and reading the annual report, because you discover useful pieces of information like this. All right, and the first thing to notice about it is how absolutely insane the numbers are on this chart. So, if you look at the amount of money that is being handed out to creators, then there's about 4 million creators, and that's active creators. That's like in the last year, how many people actually created a game on Roblox? And there's 4 million of them did it for fun. So they are almost certainly um, uh, kids mucking around with their friends. You know, they discovered from the sibling of one of their friends that they created an obstacle course in Roblox, and they were like, "Oh, I'll try that." And so they put an obstacle course together. They play around doing it with their friends. They have a fun time. You know, I've done this. I got about half an hour's worth of entertainment from hanging around with people on it's raining bombs. That was the game that I created. So it's fun doing this, right? And that's 4 million people did that. Right, and then you look at the other end of that chart, and you can see there's each creators where the amount of money that they receive is measured in tens of millions of dollars. Um, right, and so that is like A, those numbers are very big, and B, those numbers vary insanely. So you get very different numbers out of looking at Roblox, depending what you measure. Because there are two perfectly sensible units of measurement, one of which is dollars and one of which is numbers of people. And if you measure in terms of income, then there is a very small number of very professional studios creating experiences. And you can see like there's 456 creators where their experience playing time is measured in tens of millions of hours. So like top game is I think it's about 1 billion hours. Right, okay. So this is very important, and it's very important because it's what brings people to Roblox. So a lot of people start interacting with robots because there are rich interactive experiences they can take part in. And those, on the whole, are produced by a small number of professional studios. That's one way of measuring what's going on with robots. The other way of measuring what's going on with robots is number of creators. Right, and now that gets you a very different picture where there's millions of creators, and on the whole, they're not professionals, and on the whole, they skew young. So if you think, if I was recommending to a 14-year-old who is kind of interested in learning programming, how would they go about doing it? One of the perfectly sensible choices is Roblox. So we are not the only starting programming environment, but we are a perfectly sensible choice for beginning environments. So we have like hundreds of code camps that teach people how to program using Roblox. And both of these measurements are important. So both the revenue measurement and the number of people measurement are important. So one of these is the kind of life and blood of the company and brings people in and provides high quality experiences. And another one provides, people getting started on programming for the first time and, bringing enthusiasm and excitement to the platform. So both of those ways of approaching programming are very important. Right, okay. And they funnily have very different goals. So if you're a professional developer, right, go and read the huge literature about how to provide tools for code quality. So, this is exactly what your traditional type system is about. Is about giving you mechanisms for ensuring code quality goals for your program. Right. Whereas your beginning creators have very different goals that they're wanting to have satisfied. So at the point where they discover they need to do some scripting, it's because they hit a problem in their experience that they cannot solve just using the physics engine. Right? So they've discovered something like the player steps on the bridge and the booby trap goes off and the bridge collapses. Right, okay, that, funnily enough, is not built into the physics system. You have to write a script for it, and there will be some immediate goal like that they have in mind when they start using scripting. They are not, on the whole, interested in learning programming, and they're not, on the whole, interested in code quality. So they have a very different selection of goals compared to the professionals. Oh yeah, and it's not completely black and white. There is a sliding scale here. Beginners, a small percentage of those beginners go on to become professionals. Right now, the thing that both of these communities have in common is that on the whole, they don't care about type errors. So, why would they want a type system um, in their development environment? And it's not because of script analysis. So even for the people who are professional enough to be using the code quality tools, only about 10% of them switch on error reporting. So 90% of them just ignore anything to do with type errors. So given that that's the case, why on earth do we run type checking? Right, and the reason is there's lots of other tools that are type directed, not just your kind of traditional type error reporting. So things like autocomplete and API documentation and go to declaration, yada yada yada. Right, all of that is driven by the type system. And both communities are interested in that. So everybody wants good autocomplete. Right. Okay. So we've got this very heterogeneous creator community. Right. The way that for us that impacts the technical development of the type system is that everything here is undecidable. So in particular, predicting whether a runtime error will happen or not. That's an undecidable problem. Right, so you have to make a decision of, are you going to go for a system with no false positives or a system with no false negatives? So are you going to go for a sound system or a complete system? Right, and there's a huge amount of literature on sound systems. Right, there is some literature on complete systems. So things like incorrectness logic and the elixir system, but they're not as common in the programming languages community. Right, whereas Luau has taken the position we want to support both of these. So we've got a mode. When you opt into type checking, you decide, do you want to be in strict mode or non-strict mode? And those have, one of those is intended to be sound, and one of them is intended to be complete. So on the whole, we try to minimize the number of false positives in non-strict mode and the number of not false negatives in strict mode. Right, okay. So back to what we said 2 years ago. What have we done since then? Right, okay. So first of all, we've done semantic subtyping. So semantic subtyping is subtyping the way you think it should work. Types are sets of values. Subtyping is subset inclusion. It's but that's kind of obviously what type systems are. Right, okay. That's not quite as simple as you might think. So if you go and read the gentle introduction to semantic subtyping, you will discover that you quickly get into quite nasty issues about type normalization. There is quite a lot of work to implement that goal of types or sets of values and subtyping and subset enclosure. Right. Now, the reason why we're interested in this is that people quite naturally have an idea this is what types are. And so if you do syntactically driven subtyping, you end up with false positives that you kind of like look at a program that's got some horrible mess of overloaded functions, union types, possibly intersection types, blah, 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 blah. Right, and you discover that in fact you've got a false positive that's being reported by syntactically driven subtyping. And like I said, you want to minimize the number of false positives because that's like a bad experience, bad user experience. Right. So the way we've implemented this is first of all, we do actually try syntactic subtyping. Like we do the thing that you would get if you just open tuple or whatever. And if that works, yay! You know, it is sound. So if syntactic subtyping does the right thing, then we don't need to do anything clever. But if it fails, we can't just immediately report a type error. Because that might be a false positive. And so what we do is we do type normalization. Right, and this has a potential exponential blow up because that takes your the types you've inferred and converts them into conjunctive normal form. And now you run subtyping, and on normalized types, syntactic subtyping and semantic subtyping coincide. And my goodness, there's lots of devil details. So like that I just like put one line there saying do type normalization. Right. Imagine lots of horror show stuff happens there. Right, okay. So that's one thing we've done is semantic subtyping. The other thing we've done is a bit of progress on gradual typing. So the kind of like off-the-shelf version of gradual types uses compatible typing. So you add in your any type that stands in for anything. And the idea is that you're not going to report type errors about uses of that any type. Right. And now you define a compatibility relation between types. And in particular, everything is compatible with anything. And now you use compatible typing everywhere that you would use type quality. So this is the version with type quality. There's an equivalent version for subtyping. So if you've got some function application and the function's got type F and the argument's got type T and F is compatible with TTU, then the function application's got type U. Right. Now the problem with that we've hit with compatible typing is that my goodness, this is a story of very subtle bugs. So we got this wrong quite regularly because that compatibility relation isn't transitive. And so it's very easy to forget when you're doing transitive subtyping versus when you're doing non-transitive compatible subtyping. And so we got this wrong quite regularly. Right, so what we now do is, okay, if you remember like a few sentences ago, I was saying that you don't report errors when you've used the any type. Right, that's actually what we do now. So we now think of gradual typing, at least the way we do it. We think of that as being talked about error suppression. So when is it given a failure of type checking, when do you actually report that as a type error? And so what we do is we've got an infallible type system where given any typing context at any term, we will calculate a type for it. And no matter what it is, right? And then We have a separate judgment that says, when should we report an error? And the really important thing about when we do error reporting is we have a notion of error suppressing type. And in particular, any is error suppressing. And so for those error suppressing types, we actually don't report a warning. And so we now have a distinction between what programs have a correct type. For us now, that's everything. Everything actually has a type. And when is it we suppress errors? And in particular, there's a couple of things we do on that. One of which is not the relationship between non-strict and strict mode is going to be just about when do you do error suppression. And the other thing we do with this is we suppress cascading errors. So if you've got a program that's got a type error in it, and then that type error causes subsequent type errors, we do our best to use error suppression to remove the subsequent errors. Right. And one thing that's slightly funny about this is that you can think of this because we're looking at type errors as being an important object. We actually can treat those constructively. So we actually do have a constructive statement about when do you have an error. So if you look at the HATRA formalization for all of this, then we actually do have an explicit constructive notion of when a type warning happens. Right. And slightly oddly, because of you can look at this as both being a proof and being a program. When you actually run this as a program, it turns into you run the program, it produces a type, and then you could do time travel debugging, and you can run it backwards in time and find the root cause of what happened. And we can do that in the ADA because we're keeping enough time information around in order to be able to do that time travel debugging. I would really like it if we could have a node where the real thing actually does that, and it's not just the AGDA code. Right, okay. And then we have some owls to draw, so we still have, I gave you the rough idea about what non-strict mode is, but we need to nail that down more precisely, and we need to treat the difference between strict mode and non-strict mode just as about error shipping, error suppression. Oh, and we actually do have to ship the thing, so to put it in front of users. Right, thanks.
All right, thank you, Alan, for the great talk. Now we have some time for questions. And just as a reminder, please say your name and affiliation before asking the question. So, open it up to the room.
Hi, Michael Koblenz, UC San Diego. Thanks for the talk. You mentioned that you're planning on shipping soon, but it also sounds like you have a lot of iteration involved, or you had a lot of iteration involved in the design. So I'm wondering if you could talk about kind of the iterative process that you used for design, or what design techniques you used. Maybe this is sort of repeating Jonathan's question.
Yeah, so the way that Roblox approaches that kind of iteration is that we have a beta feature shipping process where what we do is the vast majority of users of the development tools will not actually see any change. But if you want to live on the edge, then you can opt into this beta feature, and then you will get whatever the current state of of how we are shipping the changes that we're making to type inference and strict mode and non-strict mode. We are trying our best not to break people into that beta feature, but we're giving slightly weaker guarantees about that than we do for people who've not opted in, because the assumption is if you've opted in, then you're prepared to live on the edge. And so that's the process that we're going to go through for getting this in front of people.
All right.
Hi, this is Cyrus Omar, University of Michigan. So it seems like there's like a hint of motivation here around type error debugging as a user-facing feature. Is that correct, or is there something that you're working on there, or what are the
It's certainly
metrics at the end of the
something we've
day that
talked.
determine what you're doing is correct?
Yeah, so that's sort of something that we've talked about. The okay, as with all software, you end up shipping your org chart, and we have like the team that looks after the programming language, and then a separate team that looks after the UX and UI for the IDE. And so, if we were going to, if what we want to do is just like produce type error messages in front of people, we could do that just in our team, right? But anytime we want to do anything interactive, there is an entire process of like needing. We now need two teams to get to agree that this is a priority, and so it is trickier for us to get interactive tooling around type error debugging than it is just to do traditional here's a string, deal with it type errors. So we have discussed this, and we have discussed this as a cross-team project, and everybody has agreed this would be cool. But you can imagine that there is a reasonable amount of effort to go from a multi-team project where you've all said yes, we think this is cool, to the feature shipping.
Got it. Thanks.
Other questions? I have one. This is Will Creighton from Brown. I'm going to ask. We gotta talk about the elephant in the room, which is there's a new metaverse language on the block, and it's got a lot of fans, a lot of hype. You know, it's verse, and but genuinely, it's clearly targeting presumably a similar niche, but of Luau, but from Unreal or Epic or whatever. And I'm curious if you've looked at their materials and how you would contrast both the design of the language and their goals with how you think about Luau.
Okay, so I'll preface my answer with yes, we have looked at it, and yes, I have opinions, but my opinions are approximately as valid as anybody else in the room's opinions, because this is not our product. But right, so I will give you the kind of like the brief version of this, which is there are a couple of differences between the goals that Luau has and the goals that Verith has. And part of that is that, as you might have noticed, like we have given a couple of talks now over 2 years, like at a human aspect workshop, and so that for us is something that's very important. And the other thing is that we've taken quite seriously is what the experience for beginning programmers is like. Where this verse like has all kinds of cool stuff there. I'm like, they're really good people. They're really smart. They've done like technically an incredibly good bit of work of software transactional memory and explicit effect tracking. So to tame down the kind of like the non-determinism that would otherwise be part of doing a functional logic programming. So this is all really cool. That's not aimed at beginners. Like the fact that you have to like explicitly annotate every function you write with its effect. That means that you're targeting the professional developers. So the fact that we think of them there as being like this heterogeneous development community, and that both of these communities are important. That I would say is something I would highlight as a difference between what we're doing and what Verse is doing.
All right, a very measured response. Thank you. Other questions?
I try my best.
Anything else? All right, well then we'll wrap up. One more round of applause for Alan.